Okay, so we are working on section 10-3 now. This is part 3, prediction, residuals, and interpreting a regression line. So again, this is where we're going to move on to that line of best fit. So let's start first with prediction. I should say predictions. So our regression line is going to fit the form y hat. Now, y hat stands for predicted y. It's going to be based on this regression equation. It's not necessarily a true y value from the data. Y hat is predicted, y by itself is from the data. Okay, so y hat is equal to, sometimes you'll see this as a plus bx, but since our equation down here in our output is going to be given like this is how I'm going to write it. So it says b0, but really when you see it in the textbook or when you see it in a scientific paper or something like that, it's really b naught plus b1 times x. Okay, so b naught is my y-intercept, and b1 is my slope. Okay, and then again, y hat is the predicted y value. Okay, for each x value, if the x value is part of the sample data, it will have a corresponding y value. But if we plug in the x value to the equation, we can get a predicted y value, and then we'll end up comparing the predicted and the actual. So before we move on, I'm going to say be careful of extrapolation. And some of you may already know what that word means, but if you don't, we're going to come across it here as we move through our problem. So I'll explain it a little bit more there. Just keep in mind that we're going to be careful of extrapolation. All right, then let's talk about residuals. Talk about comparing the actual and predicted y values. Okay, so I'm going to abbreviate residual as resid. Okay. By the way, actually, before I talk about residuals, I want you to think about what you know about the word residual. Right? I think about like, I don't know, residual materials, things that are left over. That's how I think about it, right? If there is a residual in statistics, it's about what's left over between our prediction and our actual. So we're going to say resid is actual minus predicted. We always do the actual first. Okay, the direction is important. It would be more important if we had more time to actually go into residual plots. We're not going to do that in this class, but know there is more to do with residuals, and that is why this order is so important. So to help you remember the order, I always say it's RAP, R equals A minus P. Remember that order, RAP, okay? Now to interpret a residual, which we do need to be able to do in this class, we say the actual blank was blank, and then we say higher or lower than the predicted blank for, oh, sorry, I don't have to put a blank because I didn't say than the predicted. I'm just going to say than predicted for blank. Okay, so let's figure out what goes in these blanks. So first of all, we want to put everything in context. So it's the actual y context. If we're going to predict sugar and, I'm sorry, if we're going to predict calories based on sugar, I would say the actual calories was, and then I fill in the residual, whatever that value is, higher or lower. It depends. If the residual is positive, then the actual was higher than the predicted. So I would say higher. If the residual is negative, then the predicted was higher than the actual. But since I put it in this order, then I would say the actual is lower than the predicted whenever the residual is negative. And then I say for whatever my x value was that I plugged in, for x equal to whatever number you used. And again, put that in context. So for a sugar of 30 grams, whatever it is that you're using. Okay, well, we'll come back to that sentence in just a second when we talk about residuals in the actual context of our problem. Okay, then we need to talk about how to interpret the y-intercept and the slope. Now, before I move on to the actual interpretations here, I kind of forgot. I wanted to talk to you about the way that you have probably normally seen the equation of a line. You've probably typically seen y equals mx plus b, right? That was what you saw from algebra, where m was your slope and b was your y-intercept. Okay, so you would say for the slope is that every change in x, we have this much change in y. Okay, and then b, the y-intercept, is literally where it hits the y-axis. So if you plug in 0 for x here, 0x times whatever the slope is, that's going to be 0. You're going to end up getting y equals b, because this will again be 0. Okay, so this is the y-intercept, this is the slope. Now we changed the order of those two in our equation here for statistics. We put the y-intercept first and called it b naught, and then the slope b1. We didn't use m. So there is a good reason for this, actually. Sometimes there are not good reasons for conventions, but there is a good reason for this one. If we start with this form for linear regression, we can extend it easily to multiple regressions. We can say a multiple regression might be y hat equals b naught plus b1 times x plus b2 times, I should say b1 times x1 plus b2 times x2 plus, I don't know, maybe b3 times x3, on and on and on, right? If we have more than one variable that we're using to figure out the y value, then we would have more than one slope. Now, these aren't necessarily called slopes as you go more and more and we're not going to actually talk about how to calculate equations like this, but this is the reason we put it in this form, so that we can easily extend it. Okay, so it's really, really important that you know that b naught, or b sub 0, is the y-intercept and b1 is the slope. If you're worried that you're going to get confused, notice that the slope is whatever number is multiplying x. Okay, slope is multiplying x, and then the y-intercept is either being added or subtracted, because if the y-intercept were negative, it would be being subtracted here. Okay. All right, so let's talk about how to interpret them then. So let's first talk about the y-intercept. Again, this is when x equals 0. It's when it's along that y-axis. If you're having trouble picturing that, let's kind of come back here to our scatter plot and take a look. Okay, this is the y-axis, right? It intercepts where x, these are the x's, are equal to 0. That y-axis goes straight through where y equals 0. That is why we call it the y-intercept. And that is why we interpret it as whenever, and then you will say x equals 0 in context. Okay, it's not good enough to just say x equals 0, because what does x mean? For the case that we're looking at right now, we would say whenever the sugar is equal to 0, right? That's the context of the problem we've been dealing with. The predicted, and then we will fill in the y context. Kitten, sorry guys. The predicted y context is the y-intercept. And again, you're going to have to fill in that y-intercept. Oops, I should have not written that in pencil. Okay, so whatever that number is what you will fill in here. Okay, so then let's talk about how to interpret the slope. So we will say with each additional and then we'll say x context. So with each additional, whatever your x is, so for each additional gram of sugar, the predicted, and then you have to fill in your y context, increases or decreases, depending on whether the slope is positive or negative, by whatever your slope is. Okay. So again, with each additional x context, the predicted y context increases or decreases by the value of the slope. Okay, I think those sentences will both make a lot more sense when we actually have contexts to fill in. So next we're going to go through this regression output information for the movie candy data again and walk through all three of these different things. Okay, that'll be the next video.